Days of Norwood. These are the days of Norwood. Days of Norwood. Days of Norwood. These are the days of Norwood.
This is Lab 8, Section D, Group B. This week on Days of Norwood, we welcome you to our Halloween two-part special. Week 1, polarizing interferometers and creatures that polarize you with fear.
Bum bum bum!
Starring Corey Boone as Cornelius Bunbar, Wesley Pullen as Wilson Castaway, and Dana Krolachek as Danger McPherson.
What the? What's going on? Oh my god! What is that? Ah!
Oh my gosh. Have you guys heard there's a zombie outbreak?
Yeah, we just saw them outside.
Oh my gosh. Okay, so they're called Twyman Green zombies. Apparently they're afraid of fringes, so we can build the Twyman Green interferometer and scare them away.
Defend our home!
Defend our home!
Huzzah!
So we've determined that the best way to utilize this Twyman Green interferometer as a weapon is to put the quarter wave polarizer, the quarter wave plate, in at 45 degrees with respect to its fast axis, because the vision of the zombies is actually, there's a certain weird polymer occurring in their eyes that's making their eyes turn into linear polarizers. And in this configuration with the quarter wave plate, no matter how they look at the interferometer, they'll always be afraid of fringes because they'll always see the fringes.
Protect our home!
Protect our home!
But wait, shouldn't we look for a cure?
Break. South Norwood. Days of Norwood. These are the days of Norwood. Days of Norwood. Days of Norwood. These are the days of Norwood.
This is Lab 7, Section D, Group B. This week on Days of Norwood, Halloween Special Part 2, Luminescence and Finding the Cure in Our Inner Selves. Starring Corey Boone as Cornelius Bunbar, Wesley Pullen as Wilson Castaway, Errol Munoz as the Refined Zombie, and extra zombies somewhere. And also, Dana Krolachek as Danger McPherson.
The fringes are ready. Here come the zombies. Quick, remove the screen.
Oh no, fringes!
It's working.
It's really working. Now we just have to hope one comes in so we can. Oh my gosh. Oh my gosh. Now, go, go, go!
Look
Oh!
Now we have our zombie, what are we gonna... Oh, we need to determine what's the best cure.
Calm down.
Sorry,
Calm
I'm
down.
flustered. That really
We've
took
been
a lot out
studying
of
this
me.
all day, and we determined that within the lab we only have 4 different possibilities. All of them are fluorescent dyes. So within the lab right now we have fluorescein, eosine Y, rhodamine B, and quinine. We're doing different tests on these to figure out what their absorbance and admittance are, and we think that that can be used to cure Twyman Green zombieism.
Alright,
Let me show you what we've been doing.
sweet.
In this section of the lab, we utilize this setup. We have a halogen light source that's coming through, a holding cell for each cuvette filled with the fluorescent dye, and this is going through this fiber cable into an ocean optic spectrometer.
In case none of our dyes worked, we want to see if other things that we could find around us that can fluoresce would also work as cures. So, we got the emission spectra of some minerals we just found outside. Checked them out, got their spectra. Did the same thing for a few little wild scorpions we captured. And then also did the same thing for paper, illuminated under UV light.
So after we create a zombie unapocalypse, we can rule the world and create counterfeit money.
That's never gonna work! So, unfortunately, normal paper is made to fluoresce, while banknotes don't. That way it's very easy to check for counterfeit money, which is why the paper we looked at fluoresced, but if you looked at a dollar bill, it wouldn't.
Oh man.
We wanted to find the fluorescence lifetime of all the different dyes we were looking at. So, we used this 335 nanometer pulse laser, a high-speed detector, and an oscilloscope. We would insert our dye sample, we did this for all the different ones, so that we could look at the emission through the detector. Using the oscilloscope, we would find the time at which the signal decayed from the maximum intensity to the 1/E point that gave us the fluorescence lifetime. We found that fluorescent had the highest lifetime, which is exactly what we want for our cure.
Now that we decided that fluorescein is the cure, we decided that we wanted to check the dilution rate depending that we'll still be able to detect the absorption or the fluorescence, because really we're trying to save as much as we can because this is all we have to save the world from the zombie apocalypse. So we had a concentrated solution and began to dilute it more and more until we found that the behavior was that of pure water.
Hey Wilson, what are you doing?
Oh, I just riding on my moon.
Where'd you get those?
From my mom. Me.
Aw, it's okay. Are you scared?
Well, yeah, when I was younger, my mom gave me all these moons and stars that littered my ceiling. So whenever I got scared, I can just look up and draw on it with my UV laser.
Wilson, your mother gave me these as a token of good luck.
What?
Years ago.
Thank you.
Nephew! Alright, moment of truth. Time to see if this baby works.
What just happened?
Hooray!
I'm so glad you woke me up. I was actually on my way to the CDC. I'm a chemist, so I actually made the cure, and I put them in these glow sticks to distribute them.
Well, what do you know?
Yeah, so let's get to it. We captured the emission spectra of all these glow sticks, and here's the plot. This cure is actually a lot more efficient than the one you guys gave me. This uses chemiluminescence. There's 2 separate reactants in these. So all you need to do to have it ready to go is you snap them, and the reaction occurs. Wait for it.
Break. South Norwood, days of Norwood. These are the days of Norwood. Days of Norwood. Days of Norwood. These are the days of Norwood.
This is Lab 10, Section D, Group B. Well, this week on Days of Norwood, fiber optic coupling, fiber splicing, optical circulators, and circulating allegiances. Starring Corey Boone as Cornelius Bunbaugh, Wesley Pullen as Wilson Castaway, David Lopez as El Cochi Loco, and Ramon Orozco as El Jefe. And finally, Dana Kralichek as Danger McPherson. That was insane with the zombies. Can't believe we made it.
What a crazy couple of days.
Back to business though. How can we both be double agents?
I don't know, it's crazy. I've never really directly contacted my boss. It's always been kind of secret messages and stuff like that. How do you talk to your boss?
I've never met him either. It's just I got my mission assignment, and when I came to the optic shop, there was already an optical fiber line coming in.
Sweet, let's tap into that and figure out who your boss, our boss is.
Yeah, but this is getting kind of crazy. I think we should tell Wilson.
Okay, let's do it.
Thanks for joining us, Wilson. We have something to tell you.
We're both double agents.
Well, what do you know?
You aren't surprised?
Oh, yeah, I mean, whoa, that's insane, guys.
So, our bosses obviously pit us against each other, and we need to figure out who they are. So we're going to try and hack into our optical communication network that Dana was using to contact her boss, Danger was using to contact her boss. So we're going to be doing some work in the shop with the fibers.
Okay, well, I grew up around optical fibers. Maybe I can help out. Why don't you show me what you've been doing?
Okay, great. For this lab, we're using a 1550 nanometer laser, this power meter, and a selection of cleaved optical fibers. We wanted to find the power coupled from the laser directly into the fiber. So for the first part of the lab, we have the laser connected to this fiber and this connector, which then goes straight to this power meter. We want to do this to find the loss in these connections and the fiber itself. So the laser is putting out 2.05 milliwatts, and the detector is only getting 1.29 milliwatts or so. So there's obviously considerable loss in these connections. So that's a great start, but for the rest of this we're going to need a couple fibers and splice fibers. I really don't have much experience with that. You said you grew up around fibers, right?
You know, I did, but I haven't had much experience doing that aspect. My dad, however, is. He's El Jefe of the cartel.
What?
What?
Your dad is the boss of the cartel?
Oh, No, guys, that's the name of the fiber optics company he owns.
Ah.
So do you think that maybe he could come in and help us?
You know, actually, he can. I mean, he's visiting today. Hey, Dad.
Hey, for the next section, fiber coupling. So we have the two ends of the two cleaved ends of fibers. This end has the laser coming in, and then we're trying to get the maximum transmission into the other end that is going back to the power meter. We were trying to align using the tip and tilt stages to align it perfectly to get the maximum transmission without actually fusing the fibers together. Okay, but for more complicated things, we'll need to get someone else.
Okay, do you know where we can find a specialist?
Yeah, I have a guy for that kind of jobs right here. Hey. Okay, so for part D, we were supposed to characterize the fiber coupling with connectors, and so we connected these two FC APC connectors and disconnected them and measured the power each time.
Now we just need to splice the fibers back together. Let me show you how to do it. To splice a fiber, we first need to strip it and then clean it with ethanol. Place it in the cleaver and cleave it, and then we put it in the Ericsson fusion thingamabob and fuse it.
The most important tool we're going to have to figure out who our boss is an optical circulator. So if you imagine that the optics shop is over here and our boss is over here coming out with communication back to the optics shop, we want to be able to go in and see what he's doing without him being able to come back and see what we're doing. So the way a perfect optical circulator works is that whatever's coming in through the port, the first port will leave through the second port at maximum and have a minimum of no transmission coming through third port. When something comes through port 2, it should be almost completely transmitted out of port 3. We should have very minimal transmission through port 1. So I finally got our optical communication system to work.
Yes! Okay, what do you find out?
Well, I figured out how to tap into his newsfeed and his events. So I sent him a fake invitation, and he's actually here in the optics shop right now.
Hey.
Great. South Norwood. Days of Norwood. These are the days of Norwood. Days of Norwood. Days of Norwood.
Stop. I think. Wait, I think it stopped. It might be recording. I don't know.
No,
I need
think it
help.
stopped. It
Okay.
usually like blinks over.
Wait, we should see if we actually got that because that was beautiful.
Yeah, let's just